Hi everyone, welcome to today's tutorial. So in this tutorial we're going to discuss how you can integrate questions or functions involving partial fractions. Okay, so before we do that, we're going to look at a quick review of partial fractions. We're going to discuss how you can resolve a rational function into a partial fraction. Alright, so if you have not yet subscribed to the channel, make sure that you click on the subscription button, and if you have any questions, feel free to contact me on any of these lines here. And then don't also forget to click on the notification button so that you don't miss out every video that I'm going to be posting. Alright, so let's quickly look at the review of partial fractions, and then if you have any questions in chemistry, physics, biology, or you need help, or you carried a course you want me to help you during the holiday, feel free to contact me. We'll talk, we'll discuss how we're going to help each other. Alright, so a review of partial fractions. So let's write a function here, f of x, that is in terms of symbols. Yeah, okay, let me not even use f of x, let me just write it. Okay, so imagine we have a function that is in the form n of x. This is just a function, any function which has x. Alright, so and then down here, let's say we have linear factors. We have ax plus b, and then let's say maybe we also have another linear factor here, which is cx plus cx plus d. Okay, so if you are dealing with if you've been told to integrate a function that is in this form, the first thing that you need to do is to resolve it into a partial fraction. And what I'm going to show you only applies when the degree of the numerator is less than the degree of the denominator. But if you have the degree of the numerator greater than the degree of the denominator, you need to use long division to divide the function. The same applies when you have the degree of the numerator equal to the degree of the denominator. You also have to use long division to divide. Then you are going to resolve your results into partial fractions. So if you have anything that is in this format, if you have a fraction that is in this format, if you want to resolve this into a partial fraction, the standard is you say a plus the first factor, a over the first factor there, which is ax plus b. Then you say plus b over this is cx plus d. So if you have another factor this side, let's say you have let's say you have ex plus or let's say you also just have something like x, you can also add c this side, then over x. Or if you have another factor, depending on the number of factors that you have, you can just continue writing like that. Yeah, so this is how you deal with such a fraction. Okay, let us look at another one. What if you have something like nx, then everything over, let's say you have repeating factors, ax plus b, and then this is repeating 3 times. So how do you write this? How do you resolve this into a partial fraction? So you do this, you say a over ax plus b, and then so I'm going to show you the standards, and then we're going to take a look at 2 examples from the test. Okay, so you have b, then you have ax plus b, so this is going to be squared, then plus c, then over ax plus b to the power 3. So this is how you deal with repeating factors. So now imagine that you also have another factor this side which is different, maybe cx plus d. So this is going to be this, you are going to add another letter here, which is d over cx plus d. So this is how you deal with such. If you have x this side, you add another one, e over x. So this is exactly what you're supposed to do. But here I was just trying to concentrate on the repeating factors. So I'm going to remove these ones which I've just added. So this is how you deal with repeating factors. So let's quickly move on to the other standard. So we have another one. Let's say you have a quadratic equation that can't be factorized. Okay, if you have a quadratic equation that can be factorized, for instance, you have x squared minus 4x, okay, let me say plus 4x plus 4. This one can be factorized, so make sure that you factorize the denominator there. Yeah, so okay, let me also write it in symbolic form. So you have ax squared, you have bx plus c. So if this one can be factorized, what you just need to do is to factorize the denominator there, so that you have something like nx, everything over, you have I'm just trying to approximate the result. So you have something like, you might have something like, let me also use different numbers. You might have something like dx plus e as one of your factors, and then the other one, maybe you have fx plus g as your factors. So from here now you can resolve it into a partial fraction. Into a partial fraction, you're going to have a over dx plus e, then plus b over f of x plus g. So this is how you resolve it into a partial fraction. So now these are the main three standards that we have. Okay, there are supposed to be 4. I think the other one deals with quadratic equation that can't be factorized. So if you can factorize the quadratic equation, factorize it properly, and then resolve it into a partial fraction. But if you can't factorize it, for instance, you have something like this. You have ax squared, then plus b. Yeah, of course, this one, even if you are a genius, you can't factorize this. Yeah, you can't factorize this as long as a and b are not factors of each other, so, or are not multiples rather. Okay, so if you have something like this which can be factorized, sometimes it can even be in the form of this quadratic equation here, but you just discover that you can't factorize that quadratic equation. So what you do is you are going to write ax plus b on top, and then everything divided by the same factor that you have here, that is going to be ax squared plus b. So this is how you write it. So if you have another factor, for instance this side like x, you can also add c over x. If you have x minus 3 as a factor, you can also add c over x minus 3. This is how you do it. Very simple and straightforward. Very simple and straightforward. Okay, so this is how you deal with partial fractions that have the degree of the numerator less than the degree of the denominator. Yeah, so now what if the degree of the numerator, what if the degree of the numerator is greater than or equal to the degree of the denominator? How do you deal with such questions? So that is very simple and straightforward. So I'll take an example of, let's say you have something like, x to the power 3 plus 2x minus 1, and then over, you have something again like maybe down you have x squared plus 3. If this is what you have, how do you deal with such a situation? You can see that the degree of the numerator, which is just the power, is less than the degree of the denominator, rather it's greater than the degree of the denominator. So for such situations, same applies to the situation where you have something like this. You have x squared over x squared plus 3. when the degree of the numerator is equal to the degree of the denominator, whatever I'm going to do on this one is exactly what you do on this one. So let's quickly see how you can deal with such a situation. So you are going to use what is known as long division. So we're going to draw this one, then we write this one here, which is x squared plus 3, and then I'm going to write this under the root plus 2x minus 1. And then from there what we do is we begin to divide. So x squared into x squared into, okay, so when you're writing this one, the best way to write it, you make sure that you cover up for all the terms that are missing. So how do we cover up for the terms that are missing? Simple. Let me show you. So we say plus 0x, and then we put our plus 3 this side. So I've covered up for x here, which is missing. So I'm going to say x squared into x to the power 3. I'm going to get x. So if I multiply this x with everything this side, I'm going to have x times x squared. I'm getting x to the power 3. X times 0x, I'm getting 0x. Let me write it properly. I have plus 0. Let me just erase. So I have plus 0x, x times 3. Yeah, x. This is x times 3. Alright, so I've also observed one thing. There was a factor which was missing here. So we also have to cover up for that factor. How do we do that? We do the same. I'm going to add a 0. So this is what we're going to do. So we cover up the factor that is missing there. So we're going to have plus 0x squared. Then we have plus, I mean a term, not really a factor, but we have a term that was missing. So we have 0x squared plus 2x minus 1. Yeah, so we say x times x squared, we get x to the power 3. X times 0x, we get 0x squared. Then x times 3x, we're getting plus 3x. So here it's just a matter of subtracting. This minus that, we're getting a 0. This minus that, we're getting a 0. And 2x minus 3x, we're getting negative x. Then we have minus 1 this side. We can bring it down. This minus 1. Yeah, so we know that this can't go into x, meaning what we have here is the remainder. So writing this, we say this into that, we get x remainder, negative x minus 1, everything divided by the polynomial there, which is x to the power 3 plus 2x minus 1. So what you do here is that you just add a plus there. How have I come up with this? Simple. Remember, if you are dividing, let's say 9 over 2, what you do is say 2 into 9, you get 4, remainder 1 over 2. So this expression can also be written as 4 plus 1 over 2. This is what I've just done here. So when integrating, you integrate this alone, but this part has to be resolved into a partial fraction. Now you can follow the rules that I showed you, where oh sorry, look at what I've written here. This is not supposed to be like this. We're supposed to have this x squared plus 3. Yeah, so okay, let me just take another example. I think this one is just okay. I'll just get another example just to make you understand properly. Yeah, in this one I've made a lot of errors. Okay, so this is what you're supposed to do. So after writing this, yeah, so after writing it in this one, you can now resolve this part into a partial fraction, and then you can integrate. So if this can be integrated without resolving it, you can just do that. Alright, so let me take another example. Like I said, so imagine that we have x to the power 3 plus 2x squared minus 3, 3 x plus 1, and then we're saying over, this is x squared plus we have x squared plus let's say you have 2. Yeah, you can have x squared plus 2, and then let's say maybe you have, yeah, even this one is just okay. So this one will also do the same. You write a division line of x squared plus 2 there, and then you're going to have x to the power 3 plus 2x squared minus 3x plus 1. So we don't have any term that is missing here, so we can write it the way it is. But this one we have terms that are missing, so we have a term that is missing rather. So this term is x, so we can replace it by 0x, then we write our plus 2 there. So we say x squared into x to the power 3, say x times x squared, we're getting x to the power 3, then x times 0x, we're getting 0, so we say plus 0x squared, x times 2x, we're getting plus 2x, then we say everything divided by, you subtract here, you get a 0, you subtract there, you get a positive 2x squared, subtract there, you're getting negative 5x. So from there now, what you just need to do is to divide again. So this yeah, so we can divide. So we say this x squared into 2x squared, we're getting what? We're getting just 2. Then we multiply this by everything this side. 2 times x squared, you're getting 2x squared. 2 times 0x, we're getting positive 0x there. So we have 2 times 2 there, we're getting 4. So we're getting 4 there. So this one, when we bring it down, we're having it there. Then you can do this minus that, 0, this minus that, we have a subtraction sign there. We're getting negative 5x, 1 minus 4, getting negative 3. So we can write this in the same form that I wrote the previous question. So we can say this divided by that, the answer is x plus 2, then you put a plus there, then you write the remainder, which is negative 5x minus 3, then everything over this one, which is just what we have down there, x squared plus 2. So what you need is to see if you can integrate this without resolving it into a partial fraction. You can integrate it. So you can first start by integrating this, and then look at this one. If you can integrate it without using partial fractions, you can do that. But if needs partial fractions, then you have to resort to the previous standards which I showed you. You have to check them through and then see which one is best for you to resolve this into a partial fraction. Then after resolving, then you can integrate. Alright, so let's take a look at the questions. Alright, so on the questions, we have the first question, which is this one. So I'm going to be a little bit fast. On this one, we have the degree of the numerator being equal to the degree of the denominator. So what are we going to do with this question? So this question is simple. The first thing we're going to do is to divide using long division. So I'm going to draw my long division here. So I'm having, let me write it properly. So I'm having x squared there. There's a factor missing there. So I'm going to say plus 0x and then minus 4. Then on top there, I'm going to write my x squared. And then I'll also have plus 0x plus 0. Yeah. So we say x into x squared, I'm getting 1. 1 times x squared, I'm getting x squared. 1 times 0x, I'm getting 0x. And then 1 times negative 4, I'm getting negative 4. Then here it's just a matter of subtracting this minus that, 0, this minus that, 0, 0 minus 4, we have positive 4. So meaning we can write this as we can write this expression as 1 plus this one there, then plus the remainder is what? Is 4. 4 over, we have this part here, which is just the denominator there, which is x squared minus 4. So integrating this is just the same as integrating 1 plus 4 over, of course what we have here in the denominator is a difference of 2 squares, but first let me write it how it is. X squared minus 4, and I'll put them in brackets, and I'll say the x. So this is what that means. Okay, so let's see what we can do. So integrating 1 alone is simple, but integrating this one can't be done directly. So what we need to do is to use partial fractions. We can resolve this into a partial fraction. So how do we do that? Simple. So let me take this one alone. So I'm going to have 4 this side over x. So x squared minus 4 can also be written as x squared minus 2 squared, which can also be written as 4 over, this is a difference of 2 squares, so we write it as x plus 2 and x minus 2. So from there what we do is we can write this in the standard in the standard form, which is a, since these are just 2 different factors, we're going to say a over x plus 2, then plus b over x minus 2. So let's forget about this part. So we find the common denominator this side. So the common denominator is simply just the same things that we have there, x plus 2 and x minus 2. Then from there what we do is say this into that, we're getting this part, then this part times a, we're getting a times x minus 2, then plus b times x plus 2. So if you want, you can just say, you say a times this, you put it there, then b times that, you put it there. Then this side we have 4 over x plus 2 and x minus 2. So here it's just a matter of cancelling this and that, then we're remaining with that, because when you cross multiply there, you divide, you discover that this and that is going to cancel. So just going to remain with 4 is equal to, they're identically equal to 4a, then x minus 2, then plus b x plus 2. So here what we're going to do is to look for a number that we can replace where there's x to make this part a 0. So if I put 2 there, we say let x be equal to 2. We put 2 there, this part will become a 0. 2 minus 2 will be 0. 0 times a will be 0. So I'm going to put 2 there. This side I'm going to have 4. Then this other side I'm going to have 2 plus 2. So I'm going to have b, and then in brackets 2 plus 2. So I'm going to have something like 4 is equal to 4b. 2 plus 2 will give us 4. So when you divide on both sides there, you find that b, you divide for this side, you find the value of your b to be 1. So to find the value of a, we do the same. We say let x be equal to, we make this part a 0 so that we just remain with a. How do we do that? So we replace x with negative 2. So when I put negative 2 there, I'm going to have this side I'm going to have 4, then here I'm going to have negative 2 minus 2, I'm going to have negative 4 times a to be a, then this part negative 2 plus 2, I'm going to get a 0. So I'll just leave it like that. So if we divide everything by negative 4, we're getting the value of a to be negative 1. Alright, so having found the values of a and b, we can now do the integration. So what we can do is this expression, as I said, so a is negative 1, b is 1. So we have a negative 1, b is 1. A is negative 1, and then b is 1. So integrating this is just the same as integrating 1 plus 4 over x squared minus 4, which this is what we found. So this is just the same as integrating 1 alone with respect to x, then plus integrating. So this part, after resolving into a partial fraction, into a partial fraction, we discovered that 4 over x squared minus 4 is just the same as a was negative 1 over forgotten what I wrote. Okay, I've remembered. So the value of a, the denominator of a was x plus 2, and then the denominator of b, which we found to be 1, b was found to be 1, was x minus 2. Yeah, so this is what we found. So we're also going to say, we're also going to replace this part with this. So we're going to have negative 1 over x plus 2 dx, and then also have plus 1 over x minus 2 dx. So integrating 1 will give us x, then integrating this part, because it has a negative there, so we say minus, and we have a linear factor as a denominator there, so we say ln absolute value of x plus 2, then plus this one also, we have a linear factor as a denominator there, we say ln absolute value of x minus 2, then we say plus c. So this is the integral that we were looking for in this part. Okay, let's also take a look at another example. So for this one, the degree of the numerator is less than the degree of the denominator. So we just go direct into resolving it into a partial fraction. But before we do that, we first need to find the factors of the denominator. We need to see if we can factorize the denominator. So let us factorize the denominator. Okay, so for this one, looking at the expression, I've just realized that we can't use partial fractions. Yeah, so if you want, you can use partial fractions if you can manage to find the factors of this denominator. But looking at it, U-substitution can be the simplest way to assist to solve this fraction. Why have I said U-substitution is the best method for this expression? Is because when I differentiate the denominator, I'm going to get exactly what is on the numerator after factorizing, which means at some point what is on top there is going to cancel with what is down, or what is going to cancel with the derivative of the denominator. So let's see what I'm trying to talk about. So I'm going to say let the denominator, which is x cubed plus 6x squared plus 5, be equal to u. Or let me put it this side so that it's easier for some people to understand. We say let u, let me do this. So we say let u be equal to that. So if we differentiate this, we find du dx, we're going to get 3x squared plus, when you differentiate this one, you're going to get 12x, and then the derivative of the constant is equal to 0, so we just leave it like that. Okay, so we can make the x the subject. So when you make the x the subject, you're going to get so you're going to get du over 3 x squared plus 12x. So now we can replace it in that expression. So we have x squared plus 4x over, this one can also be written as, so we can put our du this side, and then we say over 3x squared plus 12x. Yeah, so we're differentiating the we're integrating this. So if we factorize the 3 this side, factorize 3, we're going to have something like this. So factorize if we factorize 3, we're going to have the integral, so I'm going to write 1 over 3 this side, the integral of x squared plus 4x. Then down here, if I factorize 3, I'm going to have, okay, let me write it this way so that you understand what I'm talking about. So if I factorize 3, I'm going to have x squared plus 4x. Then this side I'll have du. So you can see that what is on top there will simply cancel with what is down. Where is my expression? I have this one here. Okay, so I forgot to write u here. It's supposed to be u. Okay, to make everyone understand, I think so, where this u has come from, let me just erase and then show you exactly why I've written u down. Okay, so remember we said this expression, we said the denominator there is equal to u. So this expression can also be written as the numerator there divided by u, but of course where there is dx in this expression, I have to replace with that part. So dx is just equal to u over 3x squared plus 12. So now we can factorize. So we say on top we have x squared plus 4x, then down there we're going to have, we factorize 3, we're going to have x squared plus 4, and then we have du this side. Of course there is also this u, when you multiply u times that, are also remaining with u. So you can see that what is on top there will cancel with what is there, so we're just going to remain with 1 over 3 u, the integral of 1 over 3u du. So this 1 over 3 can be removed out, so we have 1 over 3 and then just remain with 1 over u du. So integrating 1 over u will simply just get ln u. So the answer is simply just going to be equal to 1 over 3 ln u, then plus c. But our u is equal to this part. So the final answer is just going to be 1 over 3 and then ln x to the power 3 plus 6x plus 5, then plus c. So this is exactly how you're supposed to integrate this expression. So thank you very much for watching today's tutorial. So if you have any questions, feel free to contact me on any of these lines. If you want help in anything, mathematics, physics, chemistry, or business mathematics, feel free to contact me. Then we're going to talk. And then don't forget to subscribe to the channel and also to click on the notification button so that you don't miss out the videos that I'm going to be posting. My name is Hamted. See you in the next tutorial video. Shalom, shalom.